Please welcome to the stage MIT Assistant Professor Danielle Wood.
Good morning to my fellow alum. It's so great to see you all. Thanks for being here. Hello, I am Danielle Wood, and I'm so excited to talk to you about my space-enabled research group, where we design systems, such as propulsion systems for satellites with beeswax, that are asking how we can promote sustainability on Earth and in space. You know, one of the things I love about MIT is that we do important traditional things in non-traditional ways. I was very excited recently to see an MIT news story that features some of my leadership. We have recently announced the first time we're having graduates in a formal major in African and African diaspora studies. I have the honor of serving as the faculty advisor to students like Stacy, who are graduating with this major or minor or concentration in the humanities. Now, you may be wondering why a professor in the Media Lab and AeroAstro is the faculty lead for African Studies at MIT, and why I co-teach a class in African Studies along with Professor Fox-Arrell, Michelle DeGraff, and here's why. I am an expert in the activities and the collaboration with countries all over Africa who want to use space technology to promote sustainability right here at home. You just saw a wonderful talk about the kinds of small satellite technology that's available these days, and since the 90s, countries all over Africa have been exploring how to use these tools for their own sustainability. When I was an undergrad here at MIT, I was interested in the question of how to get involved with development projects in Africa. I used to go to Kenya and to volunteer at a school. But here at MIT, I was working on the Spheres robots that were headed to the space station and thinking, is there a connection between my interest in African development and my interest in space? I wanted to work for NASA and be part of that mission. And soon I learned that countries like Kenya, South Africa, Ghana, and others have space programs. Many of them are focused on using satellite data to make better maps at home. But also, as technology was getting more and more affordable, they were very interested in using small satellites to train local engineers and be a part of the small satellite revolution you're just hearing about. So these days, I'm both interested in designing next-generation small satellite technology, but also collaborating with the countries that are creating their own domestic space programs. They're also interested in the question, how can they support progress on sustainable development goals? How many of you have seen this graph before? Do you know the SDGs? That's wonderful to see. If you don't know them, please go look them up and figure out which ones you are working on. Because the global community is engaged in an urgent mission to ensure that we are addressing our important challenges of our generation. We need to eliminate extreme poverty. It can be done. We need to coordinate on making sure everyone has access to food and water, education, opportunities for jobs. And this is something that everything can support, including our space technology. One of my areas is asking, how can we use the wonderful data from satellites, such as those operated by NASA's Earth observation systems? They take measurements of what's happening in the atmosphere, in the poles, where the global important ice loads are being held, in the ocean, in forests. There are many special kinds of data, and to be honest, it's wonderful free data, but it is hard to use. I have wonderful, highly trained students in my team, and we take a long time learning each different kind of satellite. And that means that it's a barrier for important leaders at local and national scales who are asking how they can use this data in their own countries. I often work with NASA. Recently, I received a grant from NASA as part of their Applied Sciences program. We're asking how we can make it easier and reduce the barriers for countries like Angola to use NASA satellite data. I want to give a shout out to Professor Dara Ntakabi here at MIT. He's an expert on drought decision-making, especially using satellite from NASA's SMAP data. Southern Angola is a region that faces chronic patterns of drought and floods. Local communities depend heavily on rainfall to keep their crops and animals healthy. I recently visited Angola and have been invited by their National Space Agency to work on a several-year project to apply NASA satellite data to improve their use of the mapping and decision-making during drought response. Now, they're a country that's investing in having their own space program because they believe it'll help with communications as well as these important mapping issues. And NASA provides free data that's very relevant, but of course it takes expertise to learn how to turn the NASA data into action. One of the ways we can do it is by making maps like these that show patterns based on the soil moisture. And the soil moisture can be estimated by measuring the microwave radiation from the Earth. And we're turning that into maps showing where the drought is extreme. Eventually, we'll also overlay that data with socioeconomic data and help to direct where is there the greatest need for drought response. Another example is in Ghana. They have an exciting space program called the Ghana Space Science and Technology Institute. They're also interested in radio astronomy. What you see here is the first example of the Square Kilometer Array Telescope. It's going to be a multi-continent radio telescope happening in several countries in Africa and Australia, studying the ancient history of the universe. Back here on Earth, Ghana is also concerned with how to use satellite data to track important issues like deforestation due to both legal and illegal mining. A publication we talked about recently with NASA funding highlights techniques to use NASA satellite data to identify areas where there's environmental hazards due to illegal mining in Ghana. We're doing this in collaboration with their national space program. In fact, I'm heading to Ghana later this summer, and we'll have a chance to review and see how our NASA satellite data estimates compare to local findings. Now, there's a major concern with illegal mining in Ghana. There are regions where it's pursued, especially for gold mining, in methods that do not follow the local environmental protection requirements. It leads to water pollution and, of course, deforestation at rates that are not approved. And this is an important area where biodiversity is key to preserve. We can use a combination of optical data, things that our eyes would interpret, but also three-dimensional information through LiDAR and radar measurements to estimate what kinds of mining are happening and where it's changing. Our data shows that there's an extreme amount of deforestation due to this artisanal mining, in particular that the artisanal mining is increasing its rate faster than the legally approved mining. And we can tell this based on the patterns of the mines and the land change that's happening. We also created then a map looking at the whole country based on satellite data using some machine learning to interpret the information. And we're able to make maps showing where land use is changing, where you see a change between urbanization, deforestation, agriculture. All of this is so important because the government of Ghana is dedicated to the Sustainable Development Goals. They're eager to have information to report how things are changing and to make better policies to improve life for their country. When I go there, I'm working with the Statistical Service as well, and they literally, as you see, have the poster for the SDGs, but they're the ones who are collecting all the important data to track their progress for these important goals. And we're dedicated to transferring the knowledge between our teams. They are experts on what's happening locally, and we're providing this data from satellites. Together, we can help them figure out how to make the best policies toward development. So we're so happy to share this example, and I hope that you find ways to use your technology to support the SDGs as well. Thank you so much.